Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. So today we've got Anthony, who has completed the course ROS 2 Basics in 5 days, and he will be giving us a presentation about how he managed to do the project. And first of all, we'll see how he has managed to make it run on a real robot first. So we'll see that demonstration, and then we'll get into the nitty-gritties about his project. Alright, so I'll now hand over the floor to Anthony so that he can give us a brief intro about his project as well as go into the demonstration. Okay, Anthony, whenever you're ready.
All right.
Can you be explaining what you'll be doing as you go?
Oh yeah, sorry. So I'm building the package real quick to actually have it sent to the robot, and then I'll be launching the launch file that actually runs all the code.
Okay.
And I'll explain all the code in a little bit.
All right.
All right. I've named it wrong. Okay, so this is a little bit of a time-consuming process because I ran through some problems that I'll explain later in the presentation. But basically, right now the robot is scanning for trying to find the closest wall, and it did find the left. There's a lot of prints here, but it did find the left wall being closest. So it's just getting close to it, and then it'll start wall following.
Okay.
Yeah, once it starts, I can explain a few things because it takes about 5 minutes.
Oh, it's all right. It's all right.
Okay. So as you can see, it is starting to wall follow. The distance traveled is here. These other prints here are just the conditions that the robot's going through. So as it scans the front value, the front laser value and the right laser value, it's going through the logic and it's saying, okay, do I need to move front, right, left, depending on all the like how far the values are on each laser.
Yes.
So you'll see what I mean by like why it says running front, right. We'll get into all that in a minute.
All right.
But every second it's also updating the distance traveled. So right now the robot's just going. Like I said, it does take a minute. So the reason the speeds are so slow is because between going through the simulation and the real robot, going back and forth, the simulation would run a lot smoother and faster. So when I came to the real robot, I didn't want it to act all jerky because sometimes the simulation would act jerky. So I just wanted to make sure that it actually was getting the values and not having stutters or interrupts.
Okay.
So I just wanted to make sure it would get everything correctly. And
so the speed that you chose, was it just random, or you chose the minimum speed that you could get it to go?
So it was kind of random, but kind of like
an intuitive guess.
Chosen specifically. Yeah, because like I said, in the simulation, there was some problems where if I went just even slightly faster,
yeah,
it would not capture the for the service whenever it would find the smallest wall or the closest wall.
Yeah,
it would not capture it would not capture it right. Like it would move slightly too fast and it would miss the call basically.
Okay, so
and again, when I get to the code portion, I'll show you what I mean, like where it would get stuck.
All right.
But yeah, so I apologize for it taking a while, but there was reason behind it.
It's all right. So it has to keep checking using that service to see how far the nearest OE is.
Yes, so the service runs first as the project is intended. Then it goes into the client node where the actual wall following, like what you're seeing right now, runs while it calls the action server, which is doing the distance calculations.
All right. So the service
And that's
has
what you
to
see
be.
here.
So the service is also running concurrently as it is executing the action.
Not exactly. I shut down the service once it finds the wall. So then now it's just the topic client code that runs.
Oh, okay. All right. I would like to know, how do you ensure that it avoids the wall, right? Let's say, are you doing some processing of your laser scan data to make sure that it keeps checking?
Sorry, can you repeat the question?
So because you have to ensure that it doesn't get into the wall, right? How are you ensuring that?
Mm-hmm.
How are you handling the scan data? Are you handling that in your action, or you created a separate service for that?
No, it's in this client code. The lab's
The
about to be
action
done, so I'll
client.
show you what yes, that yeah,
Oh,
the
okay.
action client and the service client are the same. I put it all in one.
I see. All right. All right. I see. All right. I think we're almost at the end. Let's get into the code and see.
Yeah.
Just leave it running.
Okay.
So
Yeah, I'll stop it. But oh, okay.
yeah, we
Yeah,
check later.
it'll detect the lap done. It'll detect the lap done here in 1 second.
Yeah,
Or it should.
that's what we want to check. So you can leave it running.
Yeah. Okay. I don't know why it didn't right now, but it should have.
Okay.
But okay. So getting
That's
into the
fine.
code.
You can stop it now. It's okay.
Oh, okay. Yeah, I apologize. It did work last night. I don't know why it didn't detect it now.
Yeah, it's all right.
So
Uncertainties, right? That's the real world.
yeah, yes, sir.
Yeah.
Okay, so this is the client. So this is both the wall follow where the wall following logic exists,
Mm-hmm.
as well as the client for the service and the action. So this is just the initial setups. So just getting all the publishers, timers set up, getting the clients,
Mm-hmm.
things like that. Then here is where I call the service server. Then I basically have it run until I get a completion. So once I go to the service code, you'll see what I mean by completion. But I basically just want this batch of code here.
Mm-hmm.
Sorry, this is the service. I want this batch of code to run, which will then get me the closest wall.
Okay.
And then until then, like I said, I just want it to run.
Okay.
So then after this completes, it then gets into the wall following, which you saw it doing.
Mm-hmm.
So it gets into the laser callback. So these are just getting the front and right values, as this is what we need to be looking for.
Right.
Then the front laser callback, this is the logic for it. So basically we need to see if the front is less than 0.5 meters away or not. So if it is less than 0.5, that means that the robot is getting close to the wall. So we need to have it turn left. And then that way it doesn't collide into the wall.
Okay.
Then otherwise, that's why you saw this printout. It would say, okay, we're good. It's not crashing to the wall. So let's go to the right laser callback. So this is where it basically has the robot sit in between 0.2 meters and 0.3 meters away from the wall using the right laser scan value.
Right.
So this is just saying, okay, am I bigger than, oh, go ahead.
So you are like controlling it using that callback, is that right?
Yes, it's mainly the front and right is the wall following
Those are the ones you're
logic.
constantly checking in that right laser callback.
Yes,
Okay.
yes. So if you were to go back and look, you would see running front okay,
Right.
right, left, else.
Okay. Okay. I see.
Yes, and this else actually should have been straight. I apologize. That was my part of my debugging, but
Alright. Okay.
yeah.
All right.
Okay, then we send the goal once the service server completes. So this calls the ODOM. Oh, sorry, the action server, which is where all the odometry's collected. So that's basically all the distance calculations. Then we get a call saying that the lap completed. So then it should stop, or sorry, it should detect that the lap was completed. Then here's where the robot should stop moving, cancel, and say completed lap. Here's the total distance traveled.
Mm-hmm.
And then this is just getting the feedback every second, as you saw, like the distance traveled.
All right.
So getting into the service code, service server code. So like I said, these are just setting initial values. That way it actually gets into the logic. And this is actually where a lot of my problems resided when making this code. So I made state values, basically state values, where it would force itself to get into certain things that way it didn't get into other pieces of the logic. So scanning the values front, right. Oh, sorry, I apologize. The left is also just a debugging thing, as I'll explain in a second. Then these are the sectors. So after it scans the right here for all the ranges, I put the front, left, back, and right into sectors. So then it will, using a threshold of 0.8, because I know depending on where the robot is, it might detect an object over 1 meter away. So I wanted it to be less than 0.8. Going through this logic, it finds the closest sector and detects it. Then it puts it into this closest S variable. So as long as it does not equal back, it will actually get started into the rest of the logic. But if it does equal back, I wanted it to basically keep moving until it found either a front, left, or right value. So
All right.
sorry, trying to speed this up a bit. So initially the states in move. So I wanted to basically run this set of code here. So as I said, depending on what it detects, front, left, or right, I wanted to then move accordingly, right? So if it detects left, as it did in the presentation, I wanted to turn left until this front value equals this target distance. The target distance is the value that it detected the closest wall, right? So as it detected left was closest, it also got the value. So if it was 0.6 meters away, it would make the target distance 0.6 and then have the front keep twisting until that front value is also 0.6 within a tolerance, of course.
Okay, I see.
So then the state goes to forward after this is satisfied. Then the robot moves forward up to 0.3 meters, and then after that happens, it gets into another state, the turn, and that's when we have the robot turn until the robot has the wall on the right side.
Okay, all right. So it's not doing the turning as it moves. It has to like change state from following to turning.
Correct. Yeah, it changes the state values. That way, like the no values got mixed up. Because, like I said, this is where most of my problems occurred.
Okay.
And I can get into that in my slides in a minute.
All right.
And then that's pretty much it for that. Then the odom recorder, which is the action server.
Right.
This is, like I said, this is just the initial values. Here, I'm actually calling the X and Y values because this is how we calculate how far the robot has traveled. Then here, we are to get the initial condition or the initial starting point after the service completes. So this is that way we know as we loop back around if the lap was completed or not. Then the timer callback is actually where the calculations and things are happening. So this is where it gets the current value. It stores the distance, ups the counter, as I'll explain in a second. This gives us the feedback, which we saw every second saying how far we've traveled. And then this is basically checking the lap completion. So I put the counter here as it would technically detect that the lap was completed at the initial start, right? Because it would be within the tolerance. This lap comp. Yeah, so I wanted to put a timer basically saying, okay, I don't want it to check it instantly. I wanted to check after it's basically started running.
Right.
So I just put 10 as a good number, and it worked for me with the speeds I used. And then after the robot does complete, it does print this completed lap and then goes back into the client and stops the robot.
Right. So in your timer callback, right? You say that's where you're doing the odometry tracking, right?
Yes, this is where all the calculations are. It's here pretty much.
Right. So is that the whole definition of your action, or do you have anything else that as in?
What do you mean anything?
Your action is the one that's supposed to be responsible for carrying out the wall following, right? It's like that's where your control logic is supposed to be for the whole wall following instance?
The way I understood it, it was all supposed to be in this client callback. Like it would all be in under one.
All right. So when you call that action, right, does it execute the whole code that's in the client?
It's reverse. The client calls this server, and because this is an async server,
Yeah.
it runs at the same time as this, which is where the wall following logic exists.
Okay. All right. I see. Yeah, why I'm saying that, right? Because your client, right? The client is the one that says begin wall following, right? It says begin wall following, and then the server is the one that's actually responsible for doing the process of following the wall, right? So
Interesting. Okay.
right.
Yeah, the way I took it was opposite.
Right.
But
That's why I was saying I want you to explain to me that what is happening in your action, right? What is happening in your action server? Because the action server is the one that's supposed to be responsible for taking all that responsibility of the control logic of following the wall, constantly checking how far is the next wall, how far am I from the closest wall on the right, right? It's supposed to be happening in that, and the odometry tracking also should be happening in there, and you're getting feedback as that action server is doing the job that the action client has requested, right? Which has been spanned by
Mhm.
the completion of your service to begin looking for the wall, right? So I think you get the flow that I'm saying here. But
Yeah, I get it. Okay, yeah, I guess I misunderstood the instructions. So I just had this action server basically just do all the calculations. And then, like I said, all the actual wall following logic was done here. And then the feedback with the custom interface
yeah,
is printed here.
all right.
So we get this every second.
All right. No, it's okay. It's okay. I'm glad you managed to get it to work, and also there is it's still an action, right? Because it's doing the preemption that we're talking about, giving a result as it progresses. So that's also good. It's also a good implementation. It's just that that's how I would approach it. That's why I was explaining it to you in that way, so you get to see the other side or another perspective.
Yeah, no, that's very good. And I did have some slides
Uh-huh.
that I did want to go over, and some of the problem actually might have been fixed had I done what you just suggested. So
I see.
as we went over, the overall goal basically was to have the robot between zero point 0.2 and zero point 0.3 meters.
Uh-huh.
If the front is less than 0.5,
Yeah.
turn because that means it's approaching the wall. The service, yeah, I mean, I pretty much went over this, but the service just runs the scans, finds the smallest wall or the closest wall,
Right.
and then goes to it. Then the odom recorder, as we went over, just sets the initial position, calculates every second,
Yeah.
and detects the lap completion.
Right. Right.
This was just the logic, but we pretty much went over that already. Then, so some of the challenges I faced.
Mm-hmm.
So as you know, I was supposed to go a week ago, right? But there was a big bug that happened. So this I didn't get the whole thing because it wouldn't fit, but this is basically it. So I was doing just minor tweaks to the tolerances and speeds.
Yes.
And as I think I altered just one little tolerance from like 0.5 to zero point 0.4 or something like that.
Yeah.
Then as I went to go build the package again, all of a sudden these paths just got like deleted. So nothing was able to
Oh.
run at all.
Okay. Okay. I see. Yeah. It was a big pain in
Yeah,
the ass.
I don't yeah, this is probably some I'm sure you guys have some reasoning for having these topic quizzes and stuff, paths, but yeah, for some reason after that I could not run it. So I had to basically restart the whole ROS check and
Oh.
like delete the one that where this bug occurred,
Okay.
make a new one, but it still didn't work. So I had to wait a couple hours and it just kind of fixed itself, I guess. I'm not sure if I did write an email, so
Very
maybe you
sorry.
guys fixed it on y'all's end.
Very sorry about that. But thanks for recording. Now we have got a reference to see what really happened. Yeah.
Yeah, yes, sir.
All right.
Then the other biggest problem. Oh, go ahead.
I thought if you had anything else, go ahead with your presentation slides. You have got about 2 more minutes.
Okay, yeah, this should not take much longer.
All right.
So the service basically was not creating a success message, like it was not sending it as you did see it do now.
Mm-hmm.
So the problem was basically I had the RCLPY shutdown. So that was happening, and in the logic, it was basically not having enough time to check. So not only did I delete this, but I also added a timer because the logic is checking every second. Let me see if I can find it. Yeah, so right here, it checks basically every second.
Mm-hmm.
So the once the wall was found, the service server was shutting down too fast. So this would just get stuck, and it would nothing would happen. It would
Okay.
not start following the wall.
Okay. Okay.
Yep.
So
Then
it wouldn't have enough
the
time to give feedback to say I found the wall.
yes, like it would just get stuck because it wouldn't even error out. It wouldn't say it wasn't found, was found. It would just get stuck. So
Okay.
I had to add a timer in the service that a 2 second timer, basically saying, okay, give it enough time to send it and actually read what's happening with the service.
All right. All right. So it did fix the problem.
Yes,
Okay.
yes, it did. Adding the timer and taking out the shutdown
Okay.
was able to fix that.
Oh, wonderful.
Yep. And then, as I'm sure you've heard before, the real robot and laser values in the simulation are very different.
Mm-hmm.
So this is the sectors. This is the part in the service, basically where it detects the front, left, back, or right, wall being close. As you can see, the numbers are very different. So finding these out was a bit of a pain and a bit of a struggle, but we were able to get through it.
Right. Right. Right.
And just as a summary, so the topics I've learned throughout this whole project was topics, right? So it's the subscribers and publishers,
Mm-hmm.
servers, the both sync and async. So the service server was a sync. Basically, I wanted it to run until it was successful.
Mm-hmm.
Then the async is like the ODOM recorder where it runs in the background as the topic ran,
Mm-hmm.
as the client ran. Then I learned about services, actions, and they're pretty cool. And there's definitely a lot of uses for them, especially in the real world. Package building and additional debugging skills. So placing logs and or print statements ever made finding the problems a lot easier.
Right, right. Wonderful. All right. Very nice presentation, Anthony. And also it had its own
Thank
challenges,
you.
right? So you had things
Yes.
to learn out of it other than just programming. So that's good. Um, I have a couple of questions. I wanted to ask you, there is somewhere in your code where you made use of re-entrant callback groups, right?
Mhm.
Can
Yes,
you
I think it was in all of them because that was.
Right, right. Okay.
Go ahead.
Why did you choose to use those, right? Can you explain to me the logic behind that choice, right? Because you have got other types of callback groups you could have used.
Okay, yeah, I just used the reentrant because when I didn't include it, it just wouldn't run everything concurrently. Like it would only run one thing, then it would like stop.
Right.
So like for a while, the service is where I really struggled with. Like
Mm-hmm.
it just that was giving me the most problems.
Right.
So at one point, this was supposed to be called like every so often, right? As long as the laser callback could with the subscription for it, right?
Yeah.
So actually, I guess I don't really need it now with my final code, but because I have it basically just run once.
Mm-hmm.
But when I did have it running multiple times, it
Mm-hmm.
would get just stuck. It would not really finish. So
Right.
I had to include this with a couple with the other callbacks.
Right. The reason why I'm asking is I want you to like tell me that you do understand what it's doing by being re-entrant, right? Versus being something else, right? So you saw that it's blocking, right? So what does it do different that doesn't allow it to block, right?
Yeah. So what I noticed, it just basically forced itself to go in there again. Like it wouldn't have some weird error where it wouldn't call it back. It would actually force itself to go in and run, like I said, concurrently with the other callbacks happening.
Mm-hmm.
Because I want this to be checked a lot as well, right?
All
This is
right.
what gives the client that the wall was found.
Right,
So if I
right.
didn't include it, this basically would not be checking.
All right, all right. So what it does, okay, what it does is your re-entrant callback groups, right? They allow you to have things run in separate threads, right? That's why it's non-blocking. So, uh, That's the important thing too,
Okay.
because your service, by nature being a service, it will block until the response comes back, right, before it continues the execution. So if you've got a service
Yes.
that you want to
Yes.
wait for, if you span it in this, if you have it carry out its tasks, or if you have that client do the waiting in a separate thread, then your robot can do execution in another thread. That's the main that's the importance of re-entry and callback rules, right? It's the fact that they can run in separate threads, so you can have a service or a service client do the waiting in a separate thread, or the server do the serving in a separate thread, and you don't have a blocking effect there. All right.
Yeah. Okay. Well, yeah, that makes sense then why it actually did work
Yeah.
whenever I did add it. So
Yeah. Yeah. All right. Very nice presentation, Anthony. Well done. Well done. And
thank you.
I think that's it for us. And I'd like to say congratulations to you. And let's just do a wrap up, and we'll finish our conversation on Zoom. Okay.
Perfect. Thank you.
All right. All right, everyone. So this was Anthony's presentation. Would like to congratulate him for a job well done, full of challenges and overcoming, and that's good because you get to figure out how to fix these things and also understand why certain things do happen. So we highly encourage you to take the courses that we offer certification on. If you are keen on those, they'll definitely aid to your learning path. So until next time, keep pushing your ROS learning. Bye bye.